I am Cody Curtin, one of the application engineers with Barnum, and today we will be setting up a Lenza i550 Ethernet IP drive from factory default all the way to getting a motor turning here on the table in front of me. The first thing you'll notice about the i550 drives here that we have on the table, this here is our cabinet version IP20 i550. We have a ProTech i550, which is a wall mountable, machine mountable, and we have the i550 Motec, which is a motor mountable. We're going to be programming the cabinet version over here, and this variation of it is modular, as you can take all the components apart. This one is Ethernet IP with a keypad on front. The keypad is going to be showing us diagnostics about what we are programming on the drive, as well as full functionality for the programming. If you want to do all of the programming and set points from the keypad, you can. When you first take this out of the box, when you first get an i550 drive, first thing you're going to have to do to get these things connected is you're going to have to go to the Lenza website, which I have shown here, and we're going to have to do a few downloads. The first download we're going to have to find is actually software to program this drive, and then we're going to have add-on instructions and EDS files. When you first come to the Lenza Engineering website, there'll be a Downloads tab up top or a Services tab. Under the Downloads tab, you can come to Engineering Software Tools, and you will have to come through and register to get the Easy Starter program. Once you have the Easy Starter program installed on your PC, connect to the internet, and it will download all of the files and all the device descriptions for all Lenza products. Once that program is up to date, you'll be ready to start programming these drives. While we're here on this website, under Downloads, we'll also go down to Engineering Data. On the Engineering Data page, we have all kinds of information to help you program these drives, and today we're going to be doing Ethernet IP, so we'll come and download our Ethernet IP EDS file. Once we have that downloaded, we'll also come down to our add-on instructions. Since we are going to be programming in Studio 5000, they have Allen Bradley AOIs for us, and we'll download the Lenza i5 product line AB AOI package. This includes AOIs for all three of the drives I have shown here on the table, the cabinet version, the ProTech, and the Motec. So when you have the Easy Starter software installed, there'll be a program called Easy Navigator, which is kind of the homepage for all of the different Lenza software applications you can do, from firmware updating to commissioning these drives. When you have Easy Navigator open, the buttons on the right are going to be your online functionality. We're online with this drive right now. It's powered up and plugged into an Ethernet, so we will be able to connect. The first button here is the online commissioning diagnostics. That's what we'll use to open Easy Starter to program the i550. So when Easy Starter opens for the first time, it's going to ask you, how do you want to add a device? We are using the online version. It's the free license for this. Means you can program any device as long as you have the device online. It asks for a communication path. The only options we have is Ethernet, but we have the other protocols to be able to select, and we're doing Ethernet IP today. Once Ethernet IP is selected, we can do a browse. From here, we can go right to our Browse tab, and it should search the local network for any connected drives, and it will sort them by MAC address. Here we see one connected, which is our drive here. It comes default with no IP address program, no subnet, no gateway. What we're going to do is select that drive, and we can actually input the IP address we want it to have. My laptop and my PLC are both going to be using a 192.168.0 IP address for this setting. A 255.255.255.0 subnet. When I hit the transfer, it will send that IP address over. And as soon as it populates up top, it was set properly. I can then select that device and insert it into my workspace. Now that Easy Starter is open, you can see my workspace here. It'll tell me exactly the device I have connected, and we have a list of devices on the left. On the left-hand side, we can see the type, IP address, firmware version, some other standard information about the drive. Now that we have Easy Starter connected and online, this is where we can do all the basic commissioning of the drive, from importing any motor data to all the advanced parameters that we want. All we're going to do is a basic setting to get this thing connected to a Studio 5000 PLC, get the motor running. So the first thing we're going to have to do from here is tell it what we are actually going to be controlling and how we want to control it. You see there's a few buttons up top to change what we want to do. The only thing we're going to have to worry about up here is our save, potentially resetting some faults, and then we can always download and upload out of this drive any parameters we do save for future reference or to restore it. This main page here is all just visual, showing us what the drive is currently doing, what's currently programmed into it. You can see there isn't much programmed in here at all. It's all zeros. So we are going to have to go into our settings tab and do some basic settings. The Lenza Easy Starter software has made it very easy for us now with a basic commissioning button right on top. We can go through that directly and import the motor information and how we want it to be controlled, or we can do it manually through all of the parameter lists here on the side, or by clicking the blue links in our software. I'm going to do it through clicking the blue links here in our software, just doing the basic things we want. If you did look at the keypad here on this drive, the keypad has some default wording across the top, and what we're going to be looking for to know that this thing is programmed correctly to be talking to your network is along the top it should say net and net for network control, and network is sending the set points. The first thing we're going to do is actually activate that network control here. We're going to change this to constant true, which means network control is always true. It's going to be on. Default set point source. It's currently out of the box looking for an analog input to tell us how fast this drive is going to be running. We also want that to be controlled by our PLC, so we're going to change that to network. So after we have our activate network control set as constant true and our default set point source as network, there is one more parameter we do need to change. The easiest way to do this is just go into your parameter list, and we are going to go down to our group 4 IO settings, and we're going to see this second one here, 402, which is functionless run. The run is currently set to digital input. We want to put this as constant true. This gives our network control, again, the option to always be allowed to run this drive. Every time you make changes to any parameter on here, it's going to tell you a parameter set has changed down low. Go up top, hit save, send these to the drive so they don't get lost. From here now, we should actually have network control on this. Our keypad should say net on the front face. If it does, now the PLC can control it, and we can set up the rest of the parameters for what this drive is connected to and then bring it into RS Logics. So we have a Lenza motor connected to this drive. It makes setup very easy where I can actually select that motor. It'll import all the data, but in most cases you may not have a Lenza drive as well. So you can import all data off the nameplate on the front. Under motor control selection here, I'll click that blue link. And there's one more blue link called motor control selection. And in here, I can enter all the default parameters that is on my nameplate on the front. If I remember correctly, I have a 0.18 kilowatt drive, and the rated speed is approximately 1365 RPM. Now remember, when you do enter values in here to hit enter, they will not take if you just click off of them. Rated motor current is 1 amp. Overcurrent monitoring under additional data. This is for your use. When do you want the drive to actually start sending you warnings? For rule of thumb, I usually do 3 to 5 times higher than my rated current. So I'm going to put 5 amps here. Rated voltage. This is a 230 volt motor, and at 230 it's rated for 50 hertz. Overspeed monitoring is also an optional thing you can do for this drive, an advanced feature, monitor it. I know this is rated for approximately 1365 RPM, so I'm going to change these just so I do get thresholds that I can monitor and get errors if need be, if for some reason the motor does overspeed. I'm going to approximately put 3,000 in here, and where it'll start actually causing errors, let's say 2,500. Now that all the motor control data has been entered, we'll save all this information into the drive, and we can actually manually test and see if this drive will control our motor. There's a manual button up top. This will move the motor, make sure the motor's not hooked up to anything you don't want to see moving. No fingers are in place. No one is in any spot to get injured. But you can then activate this and control it from the software just to make sure that you are not getting any errors, any voltage issues from the inputs that you put into Easy Starter. You can see my motor's now moving. You can visually see it. And we have some values along the bottom showing us the current voltage and speed of the motor. Once we know this is running, we're not getting any errors, we can halt this and move on to actually getting this into the PLC and controlling it with the PLC. I'll save one more time, and then Easy Starter technically does not need to be used anymore unless we want to change any more advanced parameters. Everything else will be in our PLC to get this functioning. All right, now that we have our i550 up and functioning using the Easy Starter software, we are going to bring it into our RS Studio 5000 Rockwell software and get the PLC to get this thing moving. If you remember earlier, we went to the website and we downloaded an EDS file and an AOI. First thing we're going to be doing is bringing that EDS file into our Studio 5000 software. We're using the EDS hardware installation tool here. And very self-explanatory, click through the prompts, register an EDS file. We're going to browse directly to that file we downloaded, Ethernet IP EDS. If you notice here, it says servo inverter and inverter drive. The servo inverter is a different product line through Lenza. We're going to be using the inverter drive. These are the i550s. And again, you can see there's an EDS file for each one of the products we have here on the table, the Motec, the Protec, and the cabinet one. We're going to be doing cabinet. And if you noticed in our Easy Starter software earlier, there was a spot to see the firmware, and the firmware was this 7-dot variation. So we are going to use this latest and greatest. Select the EDS and bring it in. Now to actually bring the drive into our RS Logics, we're going to add it as an Ethernet device. We're going to come down and go to New Module. And we are going to find that EDS that we just brought in. Easiest way to do this is uncheck our filters, go find Lenza, and it should be the only one that comes up. It's the only one we brought in. If we did bring in all of them, there is an option to bring in a folder of EDS files. The other variations will pop up, the cabinet, the Motec, and the Protec. We're using the cabinet drive. We'll bring that in, hit create. Now in this portion, we can name it what we want. Give it our IP address we set earlier. And then when we bring this in, there are a few changes we do have to make in order to get the data we want. So we'll have to go to this change button. And you can see it brings in its own data type for us, as well as the data sizes. What we're going to want to do is we're going to change this to an integer from a send. And then we're going to go into each one of these and verify that it is sending the data that we're going to want to see. If we come into here, into the data type, it has a few defaults. What we're going to do is we're going to add one more to this input, and it's going to be register 40, which is current fault. So then any fault the drive has is going to be bringing into our PLC logic. We'll double check what the outputs are. These are fine, we don't need to make any changes. Hit OK, accept, OK. And now we can see it's added here under our Ethernet tree. Now, when we're using the files directly from Lenza, the AOIs and EDS files were created at different times. The AOI is a bit older than the EDS, and some of the data types do not match. So when we bring the AOI in for our logic, we will need to be making a few adjustments to the AOI, but nothing major, and all the functionality will still be there. So what we're going to do now is we're going to add our AOI to our project. We're going to go to our Assets tab, Add-on Instructions, and Import. And we'll go to our AOIs that we downloaded from Lenza's website. Page through the folders, and we'll bring up this one here called i550 Actuator Speed. That's the default AOI we're going to use. It gives us all of the instructions we need to get this thing moving. We import this, you can see there's a flag by errors and warnings. There are going to be some errors because this is an older AOI that does not match the EDS like I mentioned before. We can hit OK and import this. Now that that's brought in, what we're going to have to do is we're going to have to go into parameters and local tags for the AOI. And you can see these two data types are errored out because they're referencing a 2017 version of the EDS file. All we have to do is point these at the new EDS file data types that came in. Output. And our inputs. Add those errors should go away. Now that the errors are gone, we can actually bring the AOI into our new program here in Logix, and we can set the data types to actually be usable. So we'll go into our main program, and we'll bring that AOI right onto our first line of logic. Now it gives us three options here. We have to do our outputs and our inputs. Those we just saw as those local tags that we changed. And the first one is just a custom tag we'll create. When we create that tag, it'll automatically fill in the data type with the AOI UDT that comes in with it. When we fill it in correctly, the instruction will get a description up top and the rung will not be errored out anymore. From here we can download to the PLC. So we're going to download what we have currently and verify that our i550 and our PLC are talking the way they want to. Now that the i550 is online, there's no errors. We then can go into the tags and the data for it and do some basic control. We'll go here into our control tag that we created with the AOI, monitor those tags. We can see here we have a list of the available options from Lenza by default that they put in. And if we scroll over to description, each one of these tags will have a description and tell us what they are doing. We can see here Certain ones are inputs, certain ones are outputs, depending on what we are going to be using them for. For this, all we're going to be doing is setting a basic velocity and RPM. And we have a direction, positive or negative, we can change. So I'm going to go back over here to our set velocity. For this, put 600 in general. And we're going to enable velocity because that is how we're controlling it. Once we have an RPM value set, enable set, we can then turn on enable drive, which will tell our drive to move. Now that the drive is moving, some of the other inputs come in. You can see a axis enabled turned on. You can see that it is running positive direction and it's monitoring the actual velocity, 600 RPM, which matches our input. And if we went back to our easy starter program real quick, our values along the bottom as well match 600 RPM and a Hertz value of 21.1, which is what the drive is setting forward to hit that 600 RPM. This is Cody Curtin with the HH Barnum Applications team. Thank you for watching this video on programming the i550 Ethernet IP drives. If you have any questions on programming a drive like this or any of our other offerings from HH Barnum, please reach out to applications@HH Barnum. Thank you.